Okay, cool. Thank you very much for that perspective. And yeah, what are the challenges that we have to face to get from today through all these areas that you mentioned, through NISC, early FTPC, up to Goliath and Turbo?
I think there's a very important basic context when you look at the status of roadmaps across the quantum computing hardware sector. There are real challenges in scaling up these designs to large sizes, and challenges that there's great talented teams working on them, but they're not solved yet. There's challenges around the thermal budget that I can work with inside my dilution fridge. There's challenges about the laser optics needed, scaling up the laser optics needed to control certain trapped ion architectures. There's challenges about the capabilities and components I need in my photonics platform, the components I need to build an effective integrated photonics platform. And there are real challenges across all of these approaches. When the scaling really gets serious, I tend to want to go to a modular scaling approach, and the performance of interconnect is a key challenge across almost all architectures at the moment.
Okay, and what are some highlights that you would like to make about some collaborations or new ideas to face these challenges?
There's a lot going on at the moment, and picking the highlights out is really hard. I've been struck by recent announcements about CQC and NVIDIA getting together to target next generation module architectures. That brings CQC's single flux quantum logic capability to be potentially a very interesting way to address some of those thermal challenges in the dilution fridge. Also, very striking announcement from PsiQuantum that it's introduced a VTO fabrication facility into its architecture. Quite a turnaround for them, who have been the champion of silicon on insulator in existing tier 1 fabs. But this new material gives them the ability to work with electro-optic switch components, which is potentially a great enhancement to what they can do in their architecture. Also, neutral atoms have really been championing how far we can potentially push single module sizes, and they talk about much larger single modules, potentially by going to a 3-dimensional architecture, using shuttling and using row-based addressing schemes. Lots of interesting progress on just how performant their gates are. And let's not forget as well the silicon spin progress that we've seen this year, where for the first time we've actually seen practical 2D device layouts demonstrated, or at least the bare bones of 2D device layouts demonstrated. Also, a lot of activity on quantum networking, but always keep in mind that there's different use cases for quantum networking. Some of them can tolerate lower rate and lower fidelity because they're really aimed at more long distance use cases. But if we're going to use that networking for local quantum computing, local distributed quantum computing, or inter-module interconnect, it's going to have to work much faster and with much higher fidelity than the systems we're currently demonstrating.